The year is 2154. Our planet has been ruined by environmental catastrophe. In the movie Avatar, greedy prospectors from Earth descend on the world of an ancient hunter-gatherer people named the Na'vi. Their home is a lush moon far beyond our solar system named Pandora. Could such a place exist? And could our technology and our appetite for exploration one day send us hurtling out to reach it? In fact, the supposed site of this fictional solar system is one of our most likely real interstellar targets, until a better destination turns up. Pandora orbits a fictional gas planet called Polyphemus. Its home is a real place, Alpha Centauri, the brightest star in the southern constellation of Centaurus. At 4.37 light-years away, it's part of the closest star system to our Sun. Alpha Centauri is actually two stars, A and B, one slightly larger and more luminous than our own Sun, the other slightly smaller. The two stars orbit one another, swinging in as close as Saturn is to our Sun, then back out to the distance of Pluto. This means that any outer planets in this system, anything beyond, say, the orbit of Mars, would likely have been pulled away by the companion and flung out into space. For this reason, Alpha Centauri was not high on planet hunters' lists, until they began studying a star 45 light-years away, called Gamma Cephei. It has a small companion star that goes around it every 76 years. Now it seems it also has at least one planet. That world is about the size of Jupiter, and it has planet hunters excited. Perhaps 2/3 of all the stars in our galaxy are in so-called binary relationships. That means there could be many more planets in our galaxy than astronomers once assumed. At least 3 teams are now conducting long-term studies of Alpha Centauri, searching for slight wobbles in the light of each companion star that could indicate the presence of planets. If they find a planet that passes in front of one of the stars, astronomers will begin intensive studies to find out what it's like. One of their most promising tools will be the James Webb Space Telescope, scheduled for launch in 2014 or 2015. From a position 1,000,000 miles away from Earth, it will deploy a sun shield the size of a tennis court and a mirror over 21 feet wide. The largest space telescope ever built, it will offer an extraordinary new window into potential solar systems like Alpha Centauri. With its infrared light detectors, this telescope will be able to discern the chemical composition of a planet's atmosphere. And perhaps whether it harbors a moon like Pandora. One prominent planet hunter predicted that if a habitable world is found at Alpha Centauri, the planning for a space mission would begin immediately. Here's that star duo seen by the Cassini spacecraft, just above the rings of Saturn. To actually get to this pair of stars, you'd have to travel as far as the orbit of Saturn, then go another 30,000 times further. Or put another way, if the distance to Alpha Centauri is the equivalent of New York to Chicago, then Saturn would be just 1 meter away. So far, the immense distances have not stopped us from launching missions into deep space. In 1977, the twin Voyager spacecraft were each sent on their way aboard Titan III Centaur rockets. After a series of gravitational assists from the giant outer planets, the spacecraft are now flying out of the solar system at about 40,000 miles per hour. They're moving so quickly that they could each whip around Earth in just 45 minutes. twice as fast as the International Space Station. Voyager 1 has now traveled over 110 astronomical units. That's 110 times the average distance between Earth and Sun, or about 10 billion miles. But don't hold your breath. If it was headed in the right direction, it would need another 73,000 years to travel the 273,000 astronomical units to Alpha Centauri. When it comes to space travel, we've yet to realize the dream forged by rocketeers a century ago. A Russian schoolteacher, Konstantin Tsiolkovsky, inspired generations of space visionaries with sophisticated ideas about multi-stage launch vehicles. He imagined the construction of space stations in Earth orbit, and eventually vast permanent space colonies. In time, he predicted, we'd evolve into a whole new species, Homo cosmicus. Since then, rocketry's greatest advances have centered on ways of containing explosive propellants and methods of maintaining stable flight at high speeds. The problem is that chemical rockets are just not efficient for long-distance space travel. To reach the speed needed to enter orbit around Earth, 17,500 miles per hour, the space shuttle must carry 15 times its weight in fuel. And that's efficient compared to some other